The next presenter is a beautiful lady, representative of Roscosmos Corporation, Ekaterina, who has a very rare last name, Lomonosova, and I'm sure her presentation will also be very innovative. She will tell us about the activities of our other company, VNIIEM Corporation, which handles the development of Kanopus satellites, Meteor satellites, and other satellites, including small ones, which are also included into our future plans for the development of space constellation of Russia. Hello, dear colleagues. My presentation is about the new satellite Kanopus-V-IK, which was development of VNIIEM Corporation. VNIIEM was among the first to start developing or designing the remote sensing data satellites. The first one, Omega, was launched in 1963. Subsequently, a few generations of satellites of hydrometeorological property and remote sensing satellites were launched. On the 14th of July 2017 from Baikonur, we launched successfully satellite Kanopus-V-IK, which is in addition to the existing constellation of remote sensing data satellites, whose main purpose is monitoring of natural disasters and environmental conditions, operational monitoring over particular areas on Earth, and building of topographic maps. At the moment, this constellation consists of Kanopus-V number 1, V-IK, and this constellation is as an add-on a Belarusian satellite, and by the end of the year we'll launch 2 more Kanopus satellites, and this way we'll have a constellation made up of 5 satellites. The next slide shows the outlook of spacecraft Kanopus-V-IK. Its mass is 600 kilograms. It moves along the Sun's synchronous orbit. The angle of the orbit is 97.4 degrees with a period of 94.8 minutes. Visually, we can distinguish a few blocks here of this spacecraft. First block would be the payload acquisition system, consisting of multispectral acquisition system, then a block of onboard control system, and the last block will be multi-band radiometer of near and far infrared range. Some of the elements of this craft can be seen on this picture, multispectral and IK equipment. Now about the specs. In panchromatic mode we can get images with a 23 kilometers of swath width and up to 20 meter resolution and 12 meter resolution for, and also we have near and far infrared band with 2000 swath width, 2000 kilometer swath widths. Acquisition of information in near and far infrared bands allows us to perform tasks which are impossible with the highly detailed optical systems, like detection of pockets of forest fires. When analyzing the data acquired from the IR equipment, we can identify the pockets of forest fires much easier. The images from multispectral panchromatic images would be less informative because of the smokiness of the area. Because of the same reason, this equipment is more efficient when monitoring industrial sites, monitoring of volcanic activities, and monitoring of various natural emergencies or disasters. We will use IR data for the building of thermal mapping. Next slide shows the schematic of building images based on our IR equipment. The IR radiometers use independent optical electronic blocks. On this picture you can see 4 such blocks. 2 of them are main ones and 2 are backups. The scanning is done by a flat rotating mirror. The axis of the rotating mirror or the receivers is oriented towards the direction of flight of the spacecraft. It's done opposite to, it's installed opposite to the direction, and this way we get 288 lines, and after the Earth-based processing we get one single image with the swath width of 2000 kilometers. Next, this spacecraft is being tested, and the tests will be complete in the next few months, and a few sample images acquired during its testing period, with the panchromatic image, multispectral image, and the image that identifies the pockets of forest fires in the Caspian Sea that we used with that we acquired with our IR equipment. The information is then downloaded to Hydromet and Roscosmos stations that allows us to acquire this data very quickly, which is one of the priorities of satellites of this designation. That is it. Thank you very much. Now, dear colleagues, will there be questions for Ekaterina? I would like to ask a question. Now we have one satellite with IR equipment, so what is its repeat rate or revisit rate over Russia? Productivity is one of the bottlenecks that we have. We are working on it per day. We can acquire up to 50 million square kilometers with IR equipment, but we need to discuss how to work jointly with panchromatic and multispectral equipment along with IR. We'll work on this, and I'll be able to give you full specs after the completion of the testing period. But for Ministry of Emergencies and for fighting fires, for Roslesхоз, Forestry Committee, they need to have certain frequency of observations, once every 2-3 hours. Like now, revisit time is once every day, a week. For IR equipment, once a day is possible, but again, it must be specified after the completion of the flight tests.
About 25 kilometers. Is there any dynamic threshold? How did you verify, or you're going to verify? We will provide a detailed report upon completion of the flight tests. Indeed, flight tests are underway, and they are generating a report. I guess before release of official report, it's difficult to tell what these parameters are. What I'd like to say is that all technical requirements integrated in the terms of reference are being fulfilled. As soon as we put that satellite into operation, we will officially promulgate all the results at our website, Roscosmos, I mean. What's the local flight time? I mean, do you use a morning flight in the morning? This is optical electronic, but infrared, it doesn't matter if it's day or night, right? Any other contributions from the floor? Let's thank her.